It turns out that with for loops, each of the arguments in the header to the for loop is optional. So you could, for example, do your initialization outside of the header. Here we initialize I to 0 outside the header, and notice we leave the initial semicolon in place as a place marker, and now we test I is less than 10, and then we increment I. Similarly, if we wanted to, we could remove the increment of I and move that down into the body of the for loop. And now we have something that is very much like a while loop. We can even remove the test. And now we have what is called a forever loop. This loop will run without end. It is possible, however, to put in an ending condition. Here we've put an if statement into the body of the for loop. If I is greater than 10, and we add the keyword break. Break will break out of a loop. This will work exactly the way our earlier for loop worked. We'll initialize to I. Each time through we will increment, and we will test. If I is greater than 10, we'll break out of the loop. And so we should get 10 happy birthdays. And sure enough, we do. Plus a little bit of extra material from our earlier exploration. Let's comment that out. Why you would want to do this is, of course, not obvious at the moment. But there are times that the initialization needs to happen interactively, and you might want to leave that out. And there are times that you might want to interrupt a for loop or a while loop or a do while loop with the break statement under unusual conditions where you want to break out of the loop without completing it. Not only can you break out of loops, but you can also cause loops to restart based on certain conditions. Here, and again this is very artificial, we're going to test I to see if it's equal to 5. And if it is, we're going to hit the keyword continue, which says start the loop over. Don't break out, but start over. Now if we leave it the way it is, when we hit 5, we'll hit an infinite loop because it'll never not be 5. So let's be careful about that and move the increment. This way the increment happens before the test. When the increment increments I to 5, we hit continue, we loop through an increment to 6, and then we fall through that if statement and continue on. In order to make sure that this is working, let's put a little bit of information into our happy birthday statement so that we can see what I is at each iteration. And let's run that. Happy birthday 1, 2, 3, 4, 6. It did successfully skip over 5. Finally, let's say we were counting a very large number. Let's return our for loop to something more normal for a for loop. We'll comment out what we have in our for loop to preserve that for when you examine this file. And let's create a common but larger for loop. This for loop will iterate 2,000 times. I don't want to write happy birthday 2,000 times. What I want to do is iterate 2,000 times, do some work during those 2,000 iterations, and then every 100 times I want to print happy birthday. The way I say every 100 is I say if I modulus 100 equals 0. And we're going to talk about that in just a moment. Then I can print happy birthday. The modulus operator is like division that you learned in 4th grade. When you modulus a number, you divide it, and what you get is the remainder. So if I were to say 2 modulus 9, I would divide 9 by 2 and get 4 with a remainder of 1. Modulus returns the 1. If modulus returns 0, then it's an even division. 2 modulus 8 is 4 with a remainder of 0. I modulus 100 means every time I is a multiple of 100, it will have 0 remainder and will be able to display this message. Let's run this. And what we see is happy birthday 0, happy birthday 100, happy birthday 200, 300, 400, all the way up through 1700, 1800, 1900. The modulus operator is used quite a bit in for loops to keep the user informed of updates or to otherwise do something periodically.